Hi class, here's the assignment for Monday, March 10th. We learned a lot of things about radicals and simplifying them and how to do operations. So let's just go ahead and get started. You might want to have your factor pair sheet handy. Okay, and maybe, I don't know if we'll need a calculator or not, we'll see. Okay, so we're going to simplify the square root of 90. So I need to look at 90 and look at the factor pairs, or think of the factor pairs of 90, and see which pair has a perfect square in it. So let's look at 90. Here's our factor pairs. 1 and 90, 2 and 45, 3 and 30, like that, right? So what I want to mention is that there's more than one here with a perfect square. Let's see. Do we have, no, maybe not. There's only one pair that has a perfect square, and that's this one, 9 and 10. None of these numbers are perfect squares. So we're going to use the factor pair 9 and 10. So 9 times 10. And then we have rewritten it now with the factors. So we'll take the square root of 9. Remember, that's the same as this. We can separate them. Square root of 9 is 3. And the square root of 10 we're just going to leave like that because it's not a perfect square. So we have now simplified this radical to look like this, and we have no more perfect square factors inside the radical. Okay, so to simplify this, remember we're going to need to break it into two factors. So 125, 25 times 5. And again, you could look at your sheet on the back, 125. I gave you factor pairs with the largest square root factor. So 5 and 25 would be a great pair to use here. Now, I know that the square root of 25 is 5, so I'll take that out. And we'll leave the square root of 5 inside, just like that. Number 3. We have 4 on the outside, so let's just leave that over here somewhere. And let's rewrite 63 as a factor pair with a perfect square in it. So 63, 1 and 63 we don't use, 3 and 21 are not perfect squares, but 7 and 9, there's our perfect square. So we're going to use this pair, 7 and 9. Okay, so it's 4 times, well, we can't take the square root of that one, so we'll leave that as 7. And we'll take the square root of 9, which is 3. Okay, so we take the square root of, here, I'll rewrite it again. 4 times the square root of 7 times the square root of 9. So I take the square root of 9, that's 3. And I'm going to multiply that times 4, which is 12. And this one is not a perfect square, so we'll leave it inside the radical. Number 4, 8 times, okay, we need a factor pair here. 2 times 100. Okay, again, that's in the back of your sheet here. 200, 2 times 100. I know 100 is a perfect square, so I'm going to take the square root of that, and that's 10. So I have 8 on the outside times 10. So I'm going to get rid of that one, and then we just have square root of 2. Okay, so 8 times 10 is 80, and then we have what left inside. Now, doing this because you weren't in class, and maybe you could Google, just Google simplifying radicals. And there are so many videos that can show you what I'm doing in different ways and different methods, okay? But the idea is this is looking for the biggest perfect square factor. So here we have 320. If I go over to 320, I see, here's my factor pair, 5 and 64. Square root of 5 times 64. Now I'm going to use this perfect square to take out, use this factor. This is 8 that comes out, and then the square root of 5 stays in because that is not a perfect square. So you're looking for the perfect square factor so that you can take the square root of it and take it out. I did that over and over. I look for the perfect square factor and I take the square root out. Okay, number 6. When you add and subtract radicals, you need to make sure that the radicands match when possible. So the numbers inside the symbol need to match. Okay, so let's look at number 6. We have 3 rad 5 plus 4 rad 5. So these numbers match. So we're going to add the coefficients. 3 plus 4 is 7, and that's 7 rad 5. Number 7, these two numbers don't match, but if we simplify them, they will match. So let's simplify this. This is 54. That's the same thing as the square root of 9 times 6, and there's a perfect square factor right there. And this is going to be 25 times 6. And I know these from experience, so you can try to figure these out using your own knowledge of multiplication table, or you can use your factor pair sheet. Okay? So 9 times 6 is 54. It's 54. So I'm going to take the square root of 9, that's 3. So that gets rid of that, and then we are left with the square root of 6 inside. And then over here, we have the square root of 25, that's 5. So that gets rid of that, and what's left is the square root of 6. Okay, so we simplified this to look like this, and simplified this to look like this, and now our radicands are the same, so we can add them together. 8 rad 6. Okay, number 8. The radicands do not match, but let's try simplifying and see what happens. So this one can be rewritten as 3 times the square root of 25 times 3. And this can be rewritten as 2 times the square root of 4 times 3. And this is my perfect square factor. Okay. So 3 times, I'm going to take out 5, because that's the square root of 25. And 3 stays inside. Then over here I have minus 2 times, well, I'm going to take the square root of 4, that's 2. And then the square root of 3 stays inside. So notice again, I'm taking the perfect square, and I'm taking out the square root. Perfect square, take out the square root. This becomes 15 rad 3 minus 4 rad 3. And notice now our radicals match. So 15 minus 4 is 11 rad 3. Number 9, we have rad 10 plus rad 10. These match. So I have one rad 10 here and another rad. It's like adding x plus x. Right? We have 1x plus 1x is 2x. Okay. Well, here we have 1 rad 10 plus another rad 10, so that gives us 2 rad 10s. Okay, number 10. The radicands don't all match, so we're going to simplify each one and see if we can get them to match. Alright, so 48, if you look at your factor pair sheet, you'll notice that 48 has a couple of different pairs. We have one that has a 4 and a 12, and that 4 is a perfect square. And then we have the 16. We're going to use the pair with the biggest perfect square. Remember, your perfect squares are listed here, the first 15 of them. So I don't want the one with the 4 in it. I want the bigger one. I want the one with the 16. So when I look at 48, I'm not going to use 4 times 12. I'm going to use 3 times 16. This is 3 times 16 in here. And then I can take out the perfect square. That's 4. Add 3. Now let's look at the next one, square root of 8. Well, that can be written as 4 times 2. So I can take the square root of 4, and that's 2. That comes out. And the 2 stays inside. Plus, this can be written as 4 times 3. Plus 2. I take out the square root of 4. That's 2. Add 3. Okay, so notice I have some matching radicands here. Then minus, okay, so the square root of 96, that can be written as, let's see, the product of 96. Look at 96 here, and that's not a perfect square. No, 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 no. Here's a perfect square of 4, and then if I keep looking, oh, here's a bigger one. Let's use the 16, so let's use 6 times 16. That's the factor pair we'll use because we have a bigger perfect square there. So that's 6 times 16. So this is going to be minus. Okay, I take the square root of 16 is 4, and I'm left with rad 6. Now look at what I've simplified these all to be. I have a rad 3 and a rad 3, so I can combine these. 4 plus 2 is 6. So these two can be combined. 6 rad 3. And then we have 2 rad 2 And then I have minus 4 rad 6. And we cannot combine these and these because they're not the same. And we cannot combine these and these because they are not the same. Now multiplying is different. It doesn't matter if the radicands match. Let's go ahead and do the multiplying. Remember I told you multiply what's inside times what's inside. So this is the square root of 50. Now can this be simplified? Is there a perfect square factor in there? Let's look at 50. And I see we have a 1 and a 50, no. 2 and a 25. There's a perfect square in there. Remember, you have to memorize these. There's a perfect square, 25. So I see that we can use 2 and 25. So I'm going to rewrite this as 2 times 25. So then I can take this and split it up. Well, I can take the square root of 25. That's 5. You put that number outside in front. And then you put the square root of 2. You always put the number out front. If you put it on the other side, if I put it over here, it's complicated. It looks like it could be the square root of 2 times 5. Don't write it like that. Put the outside number in front. Okay, let's do this one. Multiply the outside number times the outside number. That's 15. Now you're going to multiply the inside number times the inside number. That's 72. So 15 times the square root of 72. So now I'm going to rewrite this with factors. 72, I can use 9 and 8, but there's a bigger one. So I'm going to do it 9 and 8 first and show you what happens if you don't use the biggest one. 9 and 8. Okay, so now I take the square root of 9, which is 3. This becomes 15 times 3 on the outside, and the square root of 8 on the inside. So this is 45 square roots of 8. But I know that there's still another perfect square factor in there. I could write this as 45 times the square root of 4 times 2. There's my perfect square factor. I'll take out the 2. So this becomes 2 times 45, which is 90, rad 2. Okay. Number 12. 40 can be rewritten as, let me see this first. 40 times 90, we'll go ahead and multiply those together and we get 360. Back of your sheet, you can see 360 is a perfect square. Oh no, it's not. Sorry. 360 is 10 times 36. So there's our perfect square factor. 10 times 36. So we take the square root of the 36 and we get 6. And then we leave rad 10 inside. Get rid of that, bring that out. And 13, we multiply this times this times this. So we get the square root. These are all on the inside. 6 times 6 is 36. What is the square root of 36? Well, that happens to be a perfect square. I see it here. And if I look at 36 over here, you'll notice that we have a pair here of the exact same number, 6 and 6. So the square root of 36 is going to be 6. Okay, here we have 3 times 4 is 12, times 6 is the square root of 72. Alright, so let's look at 72. Oh, look at this one. We have a big square root here, a perfect square. We could use 2 and 36. We could use 9 and 8 and then do it again, like do it more than once. We could use 4 and 18 and do it more than once. But if we use the biggest perfect square of 36, then it goes faster. So we're going to rewrite this as 2 times 36. And since 36 is a perfect square, we can take out that square root of 6. And what's left is the square root of 2. For the special skill when multiplying, when you multiply a radical times itself, it gets rid of the radical sign, so you just get 6. Now, if you want to do it the long way, you could say, well, this is inside of the radical, and this is inside of the radical, so I get the square root of 36. Well, the square root of 36 is 6. This is 11. This is the square root of 15 times the square root of 15. That's 15. This is the square root of 64, or 8 times 8. Let's do it like this. Well, since we have a pair of 8s, we can just take one out, and our answer is 8. Another way you could do this is you could say that's the square root of 64, which is also 8. Multiply the outside times the outside, that's 12. The inside times the inside, oh look, these are the same number, so it's 5. Right? You could say it's square root of 25, but that just equals 5. And then we get 60. So the outside numbers are 12, and the inside numbers are going to be the square root of 25, which is 5. Okay, rationalizing the denominator means eliminate the radical on the bottom. So let's do another. These are kind of small fractions. Alright, so we have 6 over rad 2. Remember, you can't have a radical on the bottom if it's going to be simplified. So I'm going to multiply top and bottom by square root of 2. If I multiply this by square root of 2, it just becomes rad 2 times rad 2 just becomes 2. Now I have to do the same thing to the top. So I get 6 rad 2 on the top. So I get 6 rad 2 and then 2 on the bottom. So I have no more radical on the bottom. But I do need to simplify where I can. And here I have 6 divided by 2. So that can be simplified on the outside. The outside can be simplified. So that's 3 rad 2. 19. We have a radical on the bottom. So let's multiply it by square root of 5. Square root of 5. This becomes 5. Right, square root of 25, which is 5. And this becomes square root of 20. 4 times 5. Both of these are on the inside. Okay, but we're not done because this radical can be simplified. So let's write this in a simplified way. This could be 4 times 5 over 5. Now I can take the square root of 4, so that's 2. So I get 2 rad 5 over 5. And number 20, I have the square root of 4 on the bottom, but I don't need to multiply by square root of 4 here. I can just notice that the square root of 4 is 2. So I get square root of 5 over 2, and I've gotten rid of the radical on the bottom, and I didn't even have to multiply it by itself. I can just take the square root of 4. Okay, let's do 21. Here's our radical on the bottom. I'm going to multiply this by square root of 18, and this by square root of 18. So square root of 18 times square root of 18 is just 18. Then here we have 6 rad 18. Okay, multiply the outside, and you get 6. Inside, that. Okay. Now I'm going to simplify the numbers on the outside. So if I divide that by 6 and divide that by 6, I get 1 over 3. So I just get 1/3 times square root of 18, which is square root of 18 over 3. So I just rewrite this as square root of 18 over 3. Now, I'm not done because this can be simplified. So I can write that as 9 times 2 all over 3. That means I can take out the 3 here. So I get 3 times rad 2. Right, we can take out the square root of 9 and leave the radical sign with the 2 over 3. And then these cancel. Side, 3 over 3 is 1. So the answer is square root of 2. Okay, 22, I'm going to multiply bottom by square root of 3, top by square root of 3. Square root of 3 times square root of 3 is 3. This now, the 6 stays on the outside, and then the radical sign here is 2 times 3, that's 6 on the inside. So 6 times 1, I guess you can think of it like 6, and then square root of 2 times square root of 3 is 6. Now, 6 divided by 3 on the outside here, that's 2. And we're left with rad 6. Number 23, we can split this to square root of 24 over square root of 5. Now we need to simplify this by getting rid of the radical on the bottom. So square root of 5, square root of 5. When you do that, you get 5 on the bottom. And on the top, we get 5 times 24, that's 0 to 120. You get the square root of 120. 24 times 5 is 120, and 5 square root of 5 times square root of 5 is 5. Okay, now we need to simplify this. This is not simplified up here. So the square root of 120, we can rewrite that. Let's see. If we look at our number here, 120. 30 times 4. rewrite 120 as 30 times 4, and there's our perfect square factor that we need to eliminate. So we take the 2 out, this becomes a 2, right? And then what's left inside is the square root of 30 over 5. And we're done. Okay. Here we have, again, a fraction inside of a radical, so we can split it up. Square root of 25 over square root of 4. Square root of 25 is 5. Square root of 4 is 2. And look at that, we're done. We don't need to do anything here because we can just take the square root of 4. Okay, this one's interesting. We have the square root of these fractions, so let's separate them. Square root of 3 over square root of 5. And I'm going to make some space here. This is the square root of 5 over the square root of 3. Okay, and we want to add these together. Well, let's rationalize the denominator first. Let's see what happens. This is the square root of 5. This is the square root of 5. Right? Multiply that. We get 5 on the bottom, and we get square root of 15 on the top. And over here, I'm going to multiply this by the square root of 3, and this by the square root of 3. And so we get 3 on the bottom, and square root of 15 on the top. So I'm rewriting this in this form by rationalizing the denominator. And I'm rewriting this in this form and rationalizing. So let's add these together. Square root of 15 over 5 plus square root of 15 over 3. Now if we're going to add these together, we need to have a common denominator. So 15 would be a good common denominator. So I'm going to multiply this top and bottom by 3. 3 rad 15 over 15 plus, I'm going to multiply this by 5. 5 rad 15 over 15. And now I'm going to add these together, and I get 15 on the bottom, and then 3 plus 5 is 8, and square root of 15. That's the answer. That's a long one. That one was not a bunch of fun. Okay, let's go on to the next section. Solve for the variables. Now remember, when you're solving for variables, you're going to use a plus and minus for your answer. Okay, so here we can cross multiply, and we get x squared equals 16 times 6. So that means x squared equals 96. Now to get x by itself, basically we have to take the square root of both sides. So we get x equals the square root of 96. And we're not quite done. We do need to simplify the square root of 96, so let's look at 96. It's got a lot of factors. Are there any that are perfect squares? Well, there's a 4, and there's a 16. And so we're going to use the bigger one. So we're going to use the pair with the 16 in it. So 6 times 16 is the square root of 96. Okay. Now we're going to take the square root of 16, which is 4, and leave the square root of 6 inside. Okay, 27. Cross multiply and solve. So I think this was supposed to be, let's see, 5x equals a times 16, or 16a. So we're going to divide by 5, and we get x equals, let's change this to 16a instead of a times 16 over 5. And that one's done. And then over here, we cross multiply again. So 9 times 25 equals y squared. I want to get y by itself. I'm going to take the square root. So y equals the square root of 9 times 25. That's 45 plus 4, 18, 22. 225. Okay, I multiplied 9 times 25, and then I got the square root of 25. And I got y squared, but I took the square root of both sides. What's the square root of 225? Oh, it's a perfect square. 225, the perfect square. See how it's highlighted? 15 is the square root. So 15 equals y. Okay. Now there's some equations here. We're going to try and get x squared by itself. Subtract 1 first. We get 5x squared equals 3. then divide by 5 on both sides, and I get x squared equals 3 over 5. I need to take the square root of both sides and the square root of this. So that brings us to x, right? The square root of x squared is x. And then this is the square root of 3 over the square root of 5. I'm splitting them up. Now this would be okay. This would be okay. But I do feel like we should probably rationalize the denominator. So if I multiply this by square root of 5 and this by square root of 5, we get x equals square root of 15 over 5. So I think I would accept either answer here. Either the square root of 3 over 5 or the rationalize it. Okay, let's add 2 to both sides. Root x squared equals 5. Divide by 8. Divide by 8. We get x squared equals the square root, x squared equals 5/8, but we need to take the square root of both sides to solve. So x equals the square root of 5/8. I think we'll just leave that one for today. Okay, let's do 31. Add 144 to both sides, and we get 9y squared equals 400. Now we're going to divide both sides by 9 to get y squared by itself. And we get y squared equals the square root of 400 over 9. Now this can be simplified because I definitely see some perfect squares in here. The square root of 400 over the square root of 9. So that's going to be 20 over 2. You look at your factor sheet. 400 is 20 times 20, so the square root is 20. And the square root of 9 is 3, and there's your answer. Okay, and then these are like solving for the Pythagorean theorem. So I'm going to try to get x by itself. So let's just multiply these out first. X squared plus 9 equals 36. I'm just squaring that and squaring that. All right, now let's subtract 9. And we get x squared equals 27. And then square root both sides. And we get x equals the square root of 27. Now I made a mistake on all of these, and I need to fix it right now. When we have an x in the variable as a variable, we need to remember that the answers are going to be plus minus. So all of these answers should be plus minus, either the positive root or the negative root. Over here, plus or minus. Plus or minus. Plus or minus. This is plus or minus. And then over here, plus or minus. We do it sometimes too, because so often we're just looking for the positive root. But when we're solving an equation, we do need to have our plus minus on the answer. Okay, so let's do it for this one. This is 9 plus, this is 36 equals y squared. Add these two together and we get 45 equals y squared. And now we're going to take the square root of both sides. So we get y over here, and we get the square root of 45 here. And this is going to be plus or minus. Now, this can be simplified because it does have a perfect square factor. 9 times 5. There's a perfect square factor right there. So I can rewrite this as 9 times 5. Now I'm going to take the square root of 9, which is 3. This is plus or minus 3 on the outside. And we leave the square root of 5 on the inside. And there's our answer. Okay, that's the homework. And we'll be getting a lot of practice with these skills in this chapter. Have a nice evening.